Hello, this is a question. It says use power series to approximate the definite integral to 6 decimal places. Now pay attention, they are not asking you to find the integral, so you are not using really the integration techniques directly, you are using power series. Okay, so for power series, I need to integrate this function. Let's just first talk about this function and see if I am able to write the power series for this. I can write this as x times 1 by 1 minus x cube. So in place of plus, I wrote two negatives, okay? And this part can be compared to, you have 1 by 1 minus x, which is a geometric series from 0 to infinity x to the power n, right? So we can use this to expand the given series. Let's see. X sigma n from 0 to infinity. In place of x, what do we have? We have x cube with a negative sign. So here we'll have negative x cube power n. You see, x power n, in place of x, we have negative x cube. So if you try to see what it means, first of all, can we take x inside? That would be n from 0 to infinity, negative 1 power n, x3n times x. So everything inside has nth power, right? Negative 1, this is kind of like negative 1 here, negative 1 power n times x3, the power n is x3n times x. We can write it as negative 1 power n times x to the power 3n plus 1. Now, this series can replace this function. So that means if we want to integrate this function, let's only talk about without limits for a minute. If we just want to integrate that, that means we need to integrate this series. Okay. Now, this looks complicated, but you know what this is? These are the terms which are added and they have a negative 1 power n. It's a constant with respect to x. So this is just a constant, okay, with respect to x. That's not being affected. Only thing which we need to integrate is x with power. So we are basically simply using the power rule. So n from 0 to infinity, negative 1 power n is just a constant multiplier. The integral of this would be x power add divided by the new power. Okay, we usually write plus c, but in this case, because we have our limits, after we are done with this, we are gonna just put the limits on the right hand side. Okay, so let's write that down. Now, I want you guys to see what it actually means. Let's expand it first, right? 0 to, we will put the limits. So when I put 0 in here, that would be x squared by 2, and negative 1 power 0 is 1, minus, when I put 1 in there, negative 1 power 1 is negative 1, x power 3 plus 2 is what? 5 by 3 plus 2 is 5, plus when I put 2 in there, it's positive, x to the power 6 plus 2 8 by 6 plus 2 8 minus, and so on, right? Now, how do I put the limits? We need to put upper limits first minus the lower limit. When I put the lower limit, everything will just 0. So basically, I just need to put upper limit. So this is basically 0.3 square by 2 minus 0.3 power 5 by 2 plus 0.3 power 8 minus 0.3 power 11 by 11. Oh, the powers are same here. Sorry, this is 2, 5, and 8, plus so on. This is going up to infinity. Now, if you want to calculate this, we need to just approximate it, right? This is what kind of series? This is alternating series. right? So remember, alternating series can be calculated to by a few terms so that your error would be smaller than the next term. So I'm going to just say, if I can just add my first three terms, and then the error will be less than bn plus 1. So that will be b4. So error will be less than 0.3 power 11 by 11. So you can calculate that. So I'm saying if I just calculate three terms, then error in absolute value would be less than 1.6 times 10 raised to power negative 7. That is like, 0.0000016. That's like too big a small an error. So we are good with that, right? So what I'm saying is this integral can be just estimated by the first three terms. Add these, put it in your calculator with the correct signs, and you will get, I think you are getting this number. You can check that, right? That's a simple calculation putting in the TI calculator. So let's summarize this whole thing. We had to use power series to approximate the definite integral. We started with just the function itself, right? We expressed the function as a power series in this first component, and then we integrated that, right? When you are integrating that, it's just a power rule. You guys remember the power rule? The power rule was x the power n's integral is power add divide by new power plus c. We are not writing c in this case because it's a definite integral. So we added the power of 3n plus 1 by 1 and then divide by the new power. And now it's definite integral. We have to take from 0 to 0.3. And remember, this is not just one term. We are integrating every term. So that's why we are writing summation. We expanded that. And then we said, we put the upper limit minus put the lower limit. But when we put lower limit, it's just 0. Every term will be 0. So we just need to put upper limit, which is 0.3. We expanded it. That's an alternating series. So we can estimate that just by using first three terms. That's what we did.